All right, folks, I'm doing the gray book, test 2, free response question number 3 on page 74. Here's part A. Part A says approximate the depth of the water in the tank at t equals 4 using the tangent line approximation at t equals 5. Is your estimate greater than or less than the true value? Give a reason for your answer. All right, so to do this problem, I know I need a tangent line to the function h of x at t equals 5. So I know I need a point on my graph, and I need the slope of my tangent line. Well, you're told in the problem that when t equals 5, the depth of the water is 6 inches, so that's my point. And looking at your table, that table displays the different times and the derivative of h. So h prime at t equals 5, you're told is 0.7. So that's my slope. So my tangent line would simply be y minus 6 equals 0.7 times x minus 5. And there's my tangent line. Now that I know this, and actually I'm a bad boy, this should not be x, this should be t. Okay? Now that I have that, I can say that my depth, y, at t equals 4 would simply be plugging a 4 in for my value t. I get y minus 6 equals, what is that, 2.8 minus 5. So ultimately I get y is equal to 5.3 inches deep. Okay, question B says find the rate of change of the volume of the water in the tank at t equals 2 minutes and indicate your units of measure. All right, this is a related rates problem. So when it says find the rate of change of the volume, I'm asked to find dV dt when t equals 2 minutes. Now, because we're told in the original problem that this is a rectangular tank, right, or a rectangular prism, I know that this shape will look something like this, where I've got this rectangular tank. Yep. Now the base is always going to be a rectangle, right? So actually, let me fill this guy in right here. Again, so what's happening here is I've got water in this tank coming in, right? So the water level is, the water is being poured into the tank, so the water level is rising. Now, no matter how much the water level rises, the dimensions of the base is not going to change. It's still going to be 20 by 10. But the height of the water, call this h, that is changing, right? So I'm asked to find the rate of change of the volume when t equals 2. Well, to do this, I first have to set up my equation for volume. Since this is a rectangular prism, I know the volume equals the length times the width times the height. Now, in this case, since the length and the width are set, I can fill those numbers in. But the height of the water level is changing, so I need to put in a variable h there. So I know the volume will just be 200 times whatever the height is. Now, I can go ahead and take the derivative of this. So I know that dV dt, the derivative of the left side, has to equal, well, the derivative of the right side with respect to time is 200 times dH dt. Now, to find dV dt, if I knew what dH dt is, then I could plug that number in and solve for dV dt. Well, remember that dH dt is the same thing as h prime of t, right? They mean the same thing. And you know that h prime at t equals 2 minutes from the chart is equal to 0.5. So I know that dH dt has to equal 0.5 from the chart. And so dV dt would simply equal 200 times 0.5, which is 100. And my units would be cubic inches per, what is this, minute, right? And that's B. Part C says use a left Riemann sum with 5 subintervals indicated by the table to approximate the integral from 0 to 15 of h prime of t dt. Using correct units, explain the meaning of this definite integral in terms of the depth of the water in the tank. Alright, so if I take the integral from 0 to 15 of h prime of t dt, well, again, we can think about this in a couple of ways. The fundamental theorem of calculus would say, well, that has to equal h at 15 minus h at 0. So, if you think about this, what does h at 15 minus h at 0 represent? This represents the change in the height of the water from time equals 0 minutes to 15 minutes, or over the first 15 minutes of the water being filled into the tank. All right. Well, to do my Riemann sum, and again, I think this is pretty clear cut, I know that since I've got 5 subintervals, I'm going to go, the first subinterval will be from 0 to 2, so that first rectangle would have a width of 2, and it would be, since I'm doing a left-hand Riemann sum, times the left height of 0.4, plus the next interval will be from 2 minutes to 5 minutes, so that has a width of 3, and the left hand would be 0.5, plus the next one would be from 5 to 9, so that interval has a width of 4, times 0.7, plus the next one is from 9 to 13, which is a width of 4, and that would be times 1, plus the last one is from 13 to 15 minutes, so that interval would have a width of 2, and the height would be at 1.1. And you do all this math by hand because this is not a calculator problem. You should get V equals 13.3, and the units would be cubic inches. All right, so that should be the volume in that tank at that from 0, the change in the volume of the tank from 0 minutes to 15 minutes. It is important to note that you were never told that the tank was empty at time t equals 0, or what the initial height of the water was. So do not make the assumption that this is how much water is in the tank, because you don't know that. All I know is the volume changed by 13.3 cubic inches from time t equals 0 to time 15. Okay, so we don't know what the original volume was. All right, question D is a continuation of question C. It says, is the approximation in part C greater than or less than the actual definite integral from 0 to 15 of h prime of t dt? Give a reason for your answer. Well, again, since we know, we're told in the original problem that h double prime of t, the second derivative of h, is always greater than 0, I know then I can assume that h prime of t has to be increasing. And if h prime is increasing over the interval, then that would force all my rectangles are inscribed. And thusly, this would be an underestimate.